Hello everyone, now we're going to look at how we can write two-step equations. So if you look over here at the top left, I have several different vocabulary terms that go with the different operations. Most of these you are probably aware of, but things like with addition, we have sum, together, total, add. With subtract, we're looking at words like decreased by, difference, minus. When we're looking at multiplication, we're looking especially at the word of. Don't forget that the word of tends to usually refer to multiplication, and division, words like quotient, per, divided by, things like that. The word is right here will refer to equals. That's going to be really important as we write our equations here. There are some steps up here in the upper right, some steps to writing two-step equations. Just a few things to keep in mind. Make sure you define your variable. A good one that we'll normally use is x, but feel free to use whatever fits the context of the problem. Take the sentence word by word. Again, remember that equations have an equal sign. They are not expressions, and the word is going to mean equal here. Keep in mind that the is or was, if we're looking at past tense, is going to divide the equation into two parts. You want to decide what's not necessary. You want to translate the numbers into words, numbers, variables, operations of the problem, and you want to solve that equation. Okay, so let's go ahead and jump in. Start here. Example 1, write and solve an equation that represents the following. 5 times a number less 6 is 14. So let's look at the variable term first. The variable term is going to be this part right here that says 5 times a number. 5 times something we don't know. So for A, let's call that 5 times x, or 5x. The next part here was less 6. So where is the number part in this equation? We are subtracting 6 from 5 times x. And then is 14. Remember, the word is means equals 14. And we can go ahead and solve this equation that we've created, 5x minus 6 equals 14, by, of course, adding 6 to both sides. 5x is equal to 20. We can see that 5 times a number is equal to 20. That number has to be 4 for this to be true. In B, we have the quotient of a number and -5 less -4 is -5. So let's look at our variable term first. We have the quotient of a number and -5. So I can write that as the quotient of a number and -5 is the quotient of x and -5. Make sure you're writing that in order. Less -4, so we're subtracting -4, is -5, so equals -5. So x divided by -5 minus -4 equals -5. Let's solve. Well, we know that to subtract a negative, that is the same as just adding a positive. So to get rid of that, we'll just subtract 4 on both sides of this equation. So x divided by -5 is equal to -9. Further simplify this, or solve, I should say, by multiplying both sides by -5. Because we want to get rid of this divided by -5 here. So x is equal to positive 45. Pause the video here and try the your turn problems, and then play when you're ready to go over them. Okay, so with letter C, I should say, 7 more than the product of -5 and a number is 42. So we're actually starting with our number term here, and if we're writing it exactly as it said, we'll start with that, 7 more than something. So 7 plus something. the product of -5 and a number. That's going to be our variable term. So 5 times a number, I'll say 5 times x, or 5x here, is 42, equals 42. We'll solve by subtracting 7 from both sides. So 5x is equal to 35. So x has to equal 7. And finally, problem D, 4 times the quantity of a number minus a 3 is 72. Keep in mind here, we have a quantity in this case. We have the quantity of a number minus a 3. And we are multiplying that by 4. And we are saying that the equation is going to equal 72. So keep in mind what we talked about when we talked about the distributive property. 4 times the quantity of something. So 4 times, and then something is going to be in parentheses here. The quantity that's going to be in parentheses is the quantity of a number minus 3. So x minus 3 equals 72. So that's where we have 4 times the quantity of a number minus 3 equals 72, or is 72. So make sure that you solve by using the distributive property first. So this becomes 4x minus 12 is equal to 72. Add 12 to both sides of your equation to get rid of that 12. 4x is equal to 84, and x is equal to 21. Now let's look at some actual word problems here. So example 2. Writing and solving two-step equations from a word problem. A 1-year membership to Metro Gym costs $460. There is a fee of $40 when you join, and the rest is paid monthly. Write an equation to represent what you will pay monthly for the year-long membership, and what is the solution to this equation. So a few things we want to keep in mind here. The total membership costs $460. So we want to assume and imply here that the equation is going to equal $460. Now we just need to know what's going to go on the left-hand side of this equation. Well, we know there's a fee of $40. That's set. That doesn't change. There's a fee of $40 when we join, and the rest is paid monthly. We can assume that every month we're going to pay the same amount. So we'll add 12 times, and the monthly cost I will say is equal to the variable m. So our equation is 40 plus 12m equals 460. So we'll solve this equation by subtracting 40 on both sides. That gives us 12m is equal to 420. If we divide both sides by 12, we'll get a monthly cost of $35. Make sure you're labeling your numbers here. We don't want to leave any numbers without labels. We always want to know what these numbers are. Okay, and so keep in mind that this is the solution. It's the number that makes this true. We will always, every month, pay $35 a month. Pause the video here, and I want you to take a look at your turn 2, B, C, and D. Okay, let's go over these. So in your turn 2B, Billy has a gift card with a $150 balance. He buys several video games that cost $35 each. After the purchases, his gift card balance is $45. Write an equation to help find out how many video games Billy bought and what is the solution. So we can already see that this gift card has a $150 balance, and he buys several video games that are $35 each. And at the end of everything, he has $45 left on his card. So we want to know what situations led up to the fact that after all his purchases, he had $45 left on this card. Well, we can start with the $150 balance. So he has $150. Well, then Billy goes and spends money. He spends $35 on each video game. So in this case, for my variable term, I'm going to use, and if you use something different, that's okay. But I'm going to use the variable v for video games. And I'm going to say that there's a subtraction here. Minus 35v, because he's spending that $35. He has $150. He spends $35 on each video game, and he has $45 left. So let's solve. Subtract 150 on both sides. That gives us negative 35v is equal to negative 105. And of course, if we divide both sides by negative 35, v is equal to 3. And make sure you label this 3 video games. In C, Joaquin is ordering 5 identical sandwiches and a bag of chips. The bag of chips costs $1.25, and the entire order costs $38.75. We want to write an equation to find the price of a sandwich. What is the solution? Now, in this case, for price of a sandwich, I'm not going to use s as a variable. Remember that s looks like a 5, and we don't want to have any confusion here. So let's say that price is the variable p, because ultimately we want to know the price of each sandwich. Well, we know that he's ordering 5 identical sandwiches. That means they're all going to cost the same amount. So 5 times the price of a sandwich will give us the cost of all 5 sandwiches. He buys a bag of chips that costs $1.25. So we're saying he buys 5 sandwiches and means plus, and a bag of chips. And his total costs $38.75, so equals $38.75. So to recap, 5 sandwiches at a cost that we don't know, plus $1.25 for a bag of chips, is equal to $38.75. We'll solve. Subtract your number term from both sides. We end up with 5p is equal to $37.50. And we divide both sides by 5, and we get the price of each sandwich is $7.50. Again, label your numbers. And finally, we have D. The drama club is planning a field trip. 2/3 of the drama club will attend, in addition to 8 teachers. There are 48 people going on this field trip. Again, we want to write an equation we can use to find the number of students in the drama club. And what is the solution? So here, to know the total number of students, the number of students in the drama club, I'm going to use the variable D. So let's look at our equation here. We know that 2/3 of the drama club is going to attend. We don't know how many people are in the drama club, so we'll just say 2/3 times D. 2/3 times the number of people in the drama club, in addition to 8 teachers. That right there tells you it's going to be plus 8. And there are 48 people going on the field trip, equals 48. So we'll solve this by subtracting 8 on both sides. You're left with 2/3 of the total number of students in the drama club. 2/3 D is equal to 40. We'll solve this by dividing both sides by 2/3, which, remember, when we divide by a fraction, we keep change flip. So 40 over 1 times 3 over 2. We can simplify, and we get the value of D is equal to 60 students. So that is writing an equation from a word problem. Well, what if I give you, in example 3, an equation, and you have to give me a word problem? So if we look at A, we want to write a real world problem to represent 80 minus 3x is equal to 53. So here's an example. Kendall had $80 in her bank account. There's the 80. After she bought 3 shirts that each cost the same amount, we don't know how much those shirts cost. She bought 3 shirts that each cost the same amount, so that's why we're subtracting 3x here. She has $53 in her account. She has $53. That means we're going to be equal to 53. How much did each shirt cost? That's a word problem we can use here. And actually, I will change this and this to blue. And if we look at B, we want to write a real world problem that corresponds to the equation 10x plus 30 is equal to 100. My example that I'm giving you is Rico runs 10 times in a month. Each time he runs the same distance. So keep in mind, we don't know how much he runs each time, but we do know that he runs 10 times, each the same time. So that's where the 10x comes from. Ashley runs 30 miles in the same month. That's not changing. We know that for a fact that Ashley runs 30 miles in the same month. So we're adding 30 to that. Together, they run 100 miles. So that's where we're saying the equals 100 here. We want to know how many miles did Rico travel each time he went running. So those are some examples. I want you to write an example for C and D. And I also want you to fill out the summary at the bottom here to complete this assignment for full credit. Be ready to share one of your examples with the class, and we will discuss in class tomorrow.